everybody. Today I'm going to be making a video about the power rule and the addition rule, and this is for calculus AB, and it also applies to calculus BC as well. So what is the power rule? And these are some of the simplest derivative rules there are. And so you have the power rule as one of them and the addition rule as the other. And obviously there's the product rule and the quotient rule and the chain rule, and I'll probably cover those in another video. But for now, I'm going to deal with simple rules, and then maybe in another video I'll do more complex rules if you guys would like that. So let's begin with this, and we got y is equal to 5x to the 9th, and y is equal to 3x squared plus 2. And this is how we denote a derivative. dy dx means the derivative. If you replace all the d's here with delta, you'll notice it's just the slope, which is what the derivative is. So we have we're trying to find the derivative for 5x to the 9th, and we're gonna put it here once we get the answer, and 3x squared plus 2, and we're also gonna do that here. And also this should actually be, I think this is a bit of an inaccurate title. I'm actually adding another rule here. We got the constant rule. So let's start with the easiest one, which is the constant rule. And basically that's saying that if we have a constant, what do we do? Let's say we have a separate function here. Let's say we have g of x, and I'll use this black pen for it. And we're going to do g of x is equal to 3. What is the slope going to be of this? Or what is the derivative? What's g prime? G prime is also the other way of denoting it. This is more of a standard notation. This right here, where you put the little apostrophe, you say g prime of x, that's called Leibniz notation. I personally prefer it since I'm lazy. And so g prime of x, what would it be? What's the derivative of g of x? Well, if you graph y, basically this is y is equal to 3, or g of x is equal to 3. If we graph it, it's going to be a horizontal line. And I know that's not the best horizontal line right there. I'm sorry, guys, but assuming it was a horizontal line, which it is, it's supposed to be, the slope, it doesn't have one. It's 0. So g prime of x is literally 0 at any point. And that's actually the constant rule. If I were to have any other c here, let's say I had 500 there, it would also be 0. So no matter what g of x is equal to, as long as it's a constant, of course, so it's going to be 0. That's what the constant rule is, and it's a pretty simple one to remember. Nothing too hard, though it will be important when you get to integrals. Some people forget that plus c at the end, and if you've ever watched one of my integration videos, then you might know what that means. So either way, how do we go about solving for the power rule? So the power rule is also a pretty simple rule right here, and it's one that's usually to memorize. So I'll write it down right now, and I'll write it down in this green pen actually. And so we got y, let's say we got ax to the n power. And I know I didn't use a variable last time, but I figured since a constant is a constant, I figured I'd do something. And I'll use the standard notation, not be a bit lazy this time, and I'll do dy dx. So if we have dy dx, and I'm just going to give you the formula, it's going to be a times n times x n minus 1. And that's the power rule. It looks complicated, and it isn't. If we actually I'll just do this example right now. We just do n minus 1. What's n minus 1? The power is n, and so that means this new power is going to be 8. That means whatever we have here is going to be the power of 8. We're going to have x, x is going to stay the same. But then the constant in front of it, and by the way, this constant right here does not apply as the constant rule I was mentioning earlier. Since it's being multiplied to x, if it was being added to x, and I'll explain more on the addition rule, and you'll see it here in this example, you would apply the constant rule, but for this one you don't apply the constant rule. Technically you do if you consider plus 0, but whatever. 9 times 5 is going to be 42, 45, and so 45x to the 8th, we got that here, and so that is going to be your derivative for this y, function of y over here. You got this function of y over here, and what would you do here? For the addition rule, you basically apply it in the manner that's pretty much most intuitive. And by that I mean, I'll just write it. Let's say y is equal to g of x plus f of x. Why not? So what would we do if we wanted to find dy dx? Well, it would just be g prime of x plus f prime of x. Simple as that. You just take the derivative of what you're adding. This is it. Literally it. So that's your derivative, and this is going to be dy dx, or actually sometimes people even write y prime because they're lazy, like me. And so there you go. That's the derivative of y prime, not the derivative of y prime, that's different, but that's the derivative of y. So you can apply this right here, and you'll notice that we are actually applying both of our rules right here. We're going to be applying the power rule right here, and we're going to be applying the constant rule right here. This is 2, by the way, not z or anything. So we have 3x squared, which if we take the derivative, it's going to be minus 1 on the power here, so it's going to be x to the power of 1, and then 2 is going to move down here times 3, and it's going to be 6. So 6x to the 1 is just 6x. I could erase it, but it's kind of tedious with the eraser that I'm working with. Plus, what's the derivative of 2? If you remember the constant rule, which I talked about at the beginning of this video, it's going to be 0. So 6x plus 0 is just 6x. And so that's the derivative of this function. I hope this helped understanding the power rule, addition rule, and constant rule. Thanks for watching, guys. Be sure to subscribe.